Okay, so in this question, we're going to be trying to find the pattern that's happening to get from one number to the next. And it's the same for all of the numbers. So what you do to the 4 to get the 13 is the same as what you do to the 13 to get the 40. So when we've been doing these questions, we've typically been looking at two operations, sorry. So it's not just going to be as simple as saying, okay, well, 4 plus 9 is 13, because then when you try to add 9 to 13, you don't get 40. Okay, so when we're going from smaller to bigger, we're always multiplying for sure. So we're going to be multiplying 4 by something, and then either adding to get to 13 or subtracting. So you have to kind of ask yourself, well, what's a number you can multiply 4 by to get you close to 13? And then you decide, okay, do I have to add some to get there or subtract? And then you try it for the 13. And if it works to get 40, that same rule, then you know that that's the pattern rule. So with that explanation, see if you can get it. And then you would have to apply that rule 2 more times to end up getting the 6th number in the pattern. This next one was a visual pattern. So you have 3 different figures with different amounts of blocks. So what you want to do is you want to go to the table of values and you want to start putting in the number of blocks. So in figure 1, there's 4 blocks. So you'd write 4 over here. And then there's 9 blocks and 16 blocks. Okay. So to get the missing rows, you would either look at the pictures and say, okay, well, there's 2 rows of 2, 3 rows of 3, 4 rows of 4. So it only makes sense that if I was going to draw the 4th figure, there'd be 5 rows of 5. So 5 times 5 is 25. And then you can start to look at these numbers and see if you can figure out the actual number pattern that's happening. So you start at 4, and then you increase by 5, and then 7, and then 9. So if we're going by that pattern, it would only make sense that the next figure we'd be increasing by 11. 25 plus 11 is 36. Okay? So then when we go back to write the pattern rule, it would be start at 4 and increase by 5, and then increase by 2 more each time. That would be how we would write the pattern rule. Okay, so now I have an input-output question. So again, when we practiced input-output questions, it was always, typically, we would do 2 operations to all of the input numbers to get the output. So you're going from smaller to bigger, so you're definitely going to be multiplying. And then again, is it just that we're adding or are we multiplying? So you kind of have to just do trial and error with this until you find something that, a rule that ends up working for all of them. So yeah, thinking of a rule that I can do to all these inputs to get these outputs. So in this case, I'm going to try multiplying the input by 5. So if I multiply 2 times 5, that's going to give me 10. So then I would say, okay, well, to get to 5, I'd have to subtract 5. So 2 times 5 is 10, take away 5 is 5. Then I'd go to the next one, and I'd see if it would work. So 5 times 5 is 25, take away 5 is 20. So far, so good. I go to the next one. 8 times 5 is 40, take away 5 is 35. And the next one, 11 times 5 is 55, take away 5 is 50. So that ends up being the rule that relates the input to the output. So when you go to write that, you would say multiply the input by 5 and subtract 5 to get the output. That's how we've been practicing writing those rules. So I'd like you to try this question on your own. This question you should be able to do because we practiced this last week. So all you're doing is in each of these expressions, you're labeling which part's the coefficient, which part's the constant, which part's the variable, and which part's the operation. So this is just a vocab question, okay? If you forget which part is which, you're gonna have to go back into last week's presentations and find the examples that we did. There's a slide that labels all of the parts for you. This question, the representing situations with expressions, you need to read through it. You need to identify the important information. So you've got $7 and $890. And you're trying to figure out how we can write a general expression to represent somebody's cost, regardless of how many movies they rent in a year. So there's lots of examples from last week on online that you can refer to. I want you to try this question. And then once you have your expression, you're going to substitute this in for your variable, and you'll be able to figure out somebody's total cost. This one, substituting values into expressions. So you're just going to take what C equals and you're going to plug it in. So you're going to go 4 and then in brackets 3, take away 7 equals. So I'm just substituting the C with the number and then solving. So 4 times 5, take away 7, or 4, times 5, take away 7. C equals 7. So all I'm doing, you can notice, is I'm replacing C with what C equals. And we always write it in brackets so that it reminds us that we're multiplying. So then this would be 4 times 9, take away 7 equals. So 12 take away 7, solve that. 20 take away 7, solve that. Okay, so you can write that and finish it. This question I'd like you to try because it's just like the last one I did. So it's just substituting whatever h equals, rewrite the expression and write what h equals, and then solve. Writing expressions in words, we did lots of practice with this last week as well. So how we would write something like this is we would say the number that C represents, that's always how we describe variables, is being increased by 16. Okay, so I know you guys can do these examples. Again, if you have to go back, there's lots of examples of how to do these in the presentation from last week. So you can locate that. Solving for variables and equations, we went through 2 strategies last week. You can either do substitute or cancellation or just look at it. So for example, for this first one, you're asking yourself, well, first of all, whatever's on the left side of an equation has to equal what's on the right. So if this side equals 24, this side also has to equal 24. So you're going to ask yourself, 4 multiplied by what plus 4 equals 24. So you would figure out, well, 4 times 5 is 20, plus 4 is 24. So that means that R has to equal 5. For this next one, you're asking yourself, 30 take away 2 times what equals 10. If this side equals 10, this side has to equal 10. So you're figuring out, okay, well, 30 take away 20 is 10, and 2 times 10 is 20. So that means that F has to equal 10. Okay, so I want you to figure out the variable for all of these. Fill in the blanks. I helped you guys out with yesterday through email. For these questions, you're going to look at the relationship between the first and the second row. So just like input-output tables, you're going to figure out what operations are you doing to all of the A to get the B's. And then you're going to try to represent it as that relationship as an equation. So in this case, what you end up doing is multiplying all the A's by 6 and taking away 1. Times 6, take away 1. 3 times 6 is 18, take away 1 is 17. 5 times 6 is 30, take away 1 is 29. So when you go to write this as an equation, you're multiplying A by 6, so you're going to write B equals 6A, take away 1. So this says to get all of your B's, you're going to take whatever A is, multiply it by 6, and then subtract 1. So see if you can figure out the relationship for these ones.